In this lesson, we will learn to rewrite decimals as fractions and mixed numbers in simplest form. So as we get ready to talk about how we would turn a decimal into a fraction, let's just review real quickly what or how we can use base 10 blocks to really model decimals. So if this flat, the yellow flat, is my whole, then this red long, I call it a long, would represent 1/10 of the whole. And that's because it would take 10 of these longs to cover the entire whole. So there's 10 tenths, 10 tenths to cover the entire whole. So we can say that this would be 1/10 of the whole, 2/10 of the whole, 3/10 of the whole, and so on and so forth. So that's going to come into play a little bit later in our lesson as we talk about turning these decimals into fractions. Now, on that same note, if this is our whole, okay, and now we divide the whole up into 100 equal parts, we can see that this cube would be 1/100th of the whole. And if I take that cube, and there would be 2/100ths of the whole, 3/100ths, 4/100ths, and if I covered up that whole thing, I would have 100 of those cubes covering the whole. 100/100ths would be the whole. So again, as we get ready to turn these decimals into fractions, that will just be a good review in visualizing what these decimals are. Okay, so our first task is going to be to rewrite 1 or 2 place value decimals as fractions or mixed numbers. We're going to begin by looking at 1 place decimals. And so by looking at this decimal being represented down here, we can see that this is our whole. And so what part of the whole is shaded? Well, we have these 1, 2, 3 longs, and there are 4, 5, 6, 7, 8, 9, 10 in all. So we can see that this decimal being represented here is 3/10. Remember, 10 of these longs make up the whole, so we're dealing with tenths. And if we remember our place value with decimal, it goes ones, and then our decimal point, tenths, hundredths, and then thousandths. So 3/10, if we put that in our place value, if this were a chart, right, it would be 0.3. So the decimal is 0.3. Now, how would we write 3/10 as a fraction? Well, just hearing it, you can probably visualize what that's going to look like. We have 3 equal parts colored in, and so the 3 equal parts is represented in the numerator. And how many total equal parts is this whole divided into? There are 10 equal parts, and so the 10 equal parts is the denominator. So the fraction represented is 3/10, and the decimal is 0.3. Let's look at the next one. Okay, so this one looks a little bit different, doesn't it? We see that here is the decimal being represented. And just think to yourself, what's the first thing you notice? Okay, some of you might have said that you noticed that you have one whole that's colored in. So we have, here's a whole, that whole thing's colored in, and here's another whole, but only part of that whole is shaded in. So if we were going to write this as a decimal, we can see we have a whole number. So let's come up to our place value chart, and we can see that one whole is colored in or shaded in, And so let's see what part of the second whole is shaded in. So 1, 2, 3, 4, 5, 6. So 6 of the tenths. So if I put a 6 in the tenths place, I can see that the decimal being represented here is 1.6. Now to write that as a fraction, if I can read that decimal using my place value language, I can pretty easily hear what the fraction is going to be like. So instead of saying 1.6, we would say 1 and 6 tenths. Remember, anytime you see that decimal, we use the word and. So 1 and 6 tenths. Well, that makes it pretty easy to write our fraction. 1 and 6 tenths. So the whole number 1. And then the fraction 6 over 10. And because we want to write this in simplest form, we know that 6 and 10 share a factor of 3. So we can divide, oh, not 3, excuse me, 2. So we can divide both the denominator and numerator by 2. And 6 divided by 2 is 3, and 10 divided by 2 is 5. So in simplest form, it would be 1 and 3/5. Okay, now that we've had the chance to look at one place decimals, now we're going to look at 2 place decimals. So let's just focus on this first one here. So again, if this is my whole, if this flat is my whole, I can see now it's divided into 100 equal parts. So now I know I'm dealing with hundredths. So let's count to see how many hundredths are shaded in. 1, 2, 3, 4, 5, 6, 7, 8 hundredths are shaded in. And if I were to come up to my place value chart and show that I have 0 whole numbers, I have 0 tenths, but I have, what was it again? Was it 8? I believe so. 8 hundredths. 1, 2, 3, 4, 5, 6, 7, 8. And so I can see that writing the decimal would be 0.08, 8 hundredths. And so you can see there's 2 place values behind the decimal point. That's why we call it the 2 place decimals. So 8 hundredths, if we read that using our place value language, it's pretty easy to hear that the fraction will be 8 over 100, right? 8 hundredths. There's 100 equal parts. That's our denominator. And 8 of those parts are shaded in. So 8 over 100. Now, 8 hundredths is not in simplest form. We can divide the numerator by 4 and the denominator by 4 because 4 is a factor they both share. And 8 divided by 4 is 2, and 100 divided by 4 is 25. There we go. So in simplest form, this fraction would be 2/25. Now, just a real quick reminder about simplifying fractions. If you're asking, how did you know that 4 was a factor that they shared? Well, what I usually do is I list the factors for the numerator. So I know that 1 times 8 is 8, and 2 times 4 is 4. And those are the only numbers I can multiply together to get 8. So those are the only factors of 8. 8, 4, 2, and 1. Then I start with the largest factor, and I ask myself, is 8 also a factor of 100? Oh, excuse me, I had to sneeze. And so I say, can I multiply 8 times anything to get 100? No, I can't. So I cannot use, or I cannot divide by 8. But is 4 a factor of 100? Yes, it is. I can multiply 4 times 25 to get 100. So that's how I knew that I would use 4. Now, some of you might say, well, they also share 2 as a factor, and they do. And I could divide the numerator and the denominator by 2, but it's still not going to be in simplest you'll still have more simplifying to do. That's why you want to use their greatest common factor. Okay, so that was just a little review on simplifying. Let's look at this next one. So you may say, ooh, I noticed something a little different here in this decimal that's being represented. Okay, similar to the one above it, we see that we have some holes that are shaded in, right? We have a whole flat shaded in, another whole flat shaded in, and then we have another part of a whole. Okay, so this tells us that we're going to have some whole numbers, and in fact, we can see that there are 2 wholes. So if we come up to our place value chart, we can add that 2, and then let's see, how many tenths are being represented here? Well, I can see here's 1 long, 2 long, so there's 2 tenths, right? If we were to look at those longs, so there's 2 tenths, and then let's count the hundredths, shall we? 1, 2, 3, 4, 5, 6, 7, and there were 7 hundredths. So the decimal being represented here is 2 and 27 hundredths. Now, how would we turn 2 and 27 hundredths into a fraction or mixed number? Well, we know it's going to be a mixed number because we have the 2 wholes. And then the fractional part we have is we have 27 little cubes shaded in out of 100 total cubes. So the fraction would be 2 and 27 over 100. Now, is this in simplest form? It sure is. 27 doesn't share any factors with 100. So 27 hundredths is in simplest form. Okay, so let's just practice changing decimals to fractions or mixed numbers and changing a fraction back to a decimal, because we have to kind of be able to work both ways. So we're going to start with 2 and 5 tenths. This is written as a decimal, so we have to think about what it would be written as, or how it would be written as a fraction. Again, if you can read this decimal using your place value language, it really illustrates how it should be written as a fraction. So when we say 2 and 5 tenths, we have the whole number 2, and then 5 tenths, 5 over 10, 2 and 5 tenths. Will you try writing this one down here? I'm not going to read it to you. I want you to say it in your head and then think about reading it using your place value language and turning it into a mixed number. Okay, did you write 1 and 125 over 1,000? Because 1 and 125 thousandths. So it's 125 over 1,000. Okay, now let's work the other way. Let's start with this fraction, 110 over 1,000. Can you work backwards now? If we had 1,000, one of those three-dimensional cubes, and we had 110 of the little cubes colored in, how many thousandths would that be? Another hint is you can think about the place value chart is how would you write 110 thousandths in the place value chart? Did you think it would be 0.110? Good job. 110 thousandths. All right, last one. 4,567 thousandths. Now, you may notice that this is an improper fraction or a fraction greater than 1 because the numerator is greater than the denominator. So we know it's going to be a decimal that has a whole number, correct? But how many will it have? Well, if I take 1,000 over 1,000, right, out of 4,000 over 1,000. That's one whole. And I'm left with 3,567 over 1,000. So I can take another 1,000 over 1,000 out. That's another whole. Now I'm left with 2,567 over 1,000. So let's take another 1,000 over 1,000 out. That's another whole. Sorry, my ones aren't looking very good here. Now I'm left with 1,567 over 1,000. So let's do one more. Of course, my pen died on me. Okay, 1,000 more. Sorry for the messy handwriting. And there's another whole. So now I'm left with 567 over 1,000. So I have how many wholes? You can count them. 1, 2, 3, 4. So I have 4 ones. And the remaining fractional part is 567 thousandths, or 4.567. That would be our decimal. On each of these next problems, I want you to think through and answer the questions. Pause the video to do your thinking, and then press play when you're ready to see if your thinking matches mine. So there's 2 problems on this screen. There'll be 2 problems on this screen, 2 problems on this screen. So there will be 6 problems in all that you'll work through.